Okay, all right. So what we have done till now, we have built the basics of the AI using, the PyTorch. We used PyTorch, extensive PyTorch we used, and we tried to build the basics on that. You know, we learned how to build models, and all of that is going to be useful now in understanding what is happening inside these APIs, what we are going to explore. So basically, and we will also see, because all of the next things, they are built on PyTorch only. PyTorch is the main framework on top of which they are built. So basically, if we talk of Hugging Face, Hugging Face API, first we'll talk about the Hugging Face APIs. The pipeline, they have pipeline API, Auto API, and then they have the trainer API, all of that, whatever the training loops that we were trying to write in PyTorch can automatically be done using Hugging Face API. Yeah. So basically, all of the basic things we will be able to do using Hugging Face API. But not just that. I mean, if at all you want to go ahead and add some custom layers on top of model, which is usually not very much done in applied AI. Like I said, I mean, these are mostly the problems of research and everything, or maybe you have more depth AI engineering team and you want to explore more in terms of it, then basically you go ahead and you do all sort of things. Otherwise, most of the things will be handled by the Hugging Face API only. So Hugging Face API will make our life easier. Now we can directly go ahead and concentrate on the problems directly, right? We do not need to worry about lot of things like, we are doing lot of complex things, like we were till now we have been tokenizing the data ourselves, right? Now it's just one command and one function we need to use. Then basically, for training also, we have been, although not very complex thing, but we have been training these APIs. And not just in training, but when we were trying to generate some text, what we have done text classification, right? We have done text classification. Then what we try to do, we try to do question and answering model, Q&A model. We try to train one Q&A model. Then what did we try to use? Then we try to use, question and answering model, and then simple text generation model, text generation model. So when we were actually training, there were certain logics we had to define inside our training loop. What kind of logics? I mean, just a refresher, what kind of logics did we define inside our training loop? Basically, what we had to do. So let's say we were using question and answering model. If we were using Q&A model, and inside a Q&A model, we want that our data set would be present in form of a question, and then there would be an answer for it. We would have question and answer for it. Now basically, once we have question and answer for it, then we would have to go that, each and every, we will have to first write an encoder model, right? We did that. Then we had to write a decoder model. We also did that. you know then we had to uh, train, one word we had to train, and then we had to pass it on to decoder, and then it will decode the next word. All of these things, when we do it on the array level, all of these things become quite complex. So what Hugging Face has done, it has basically enclosed all of these complexities so that you don't have to worry about all of these complexities. Now, what was also happening, let's say if it is a text classification, if it was a text classification model, right, then we had small difference in the things. Difference in the sense that training loop, although the basic structure of training loop was same, but there were small differences that we had to do. Although text classification was the most easiest one, but as soon as we go for any encoder decoder question and answering model, right, question and answering bot, as we tried to do using encoder decoder model, then obviously there were a lot of conditions we had to do. Now similarly, based on problem, basically based on the problem, there were small differences we have to make on how the data is getting handled, right? There were small differences. So all of that all of that complexity is now handled automatically by transformer API, by all of the transformer API, right? Hugging Face API or the transformer API, right? Now, we'll talk about it. What we have discussed till now is now we will keep on discussing the transformer architecture also. What we have discussed, we did discuss in the previous uh, session was about attention mechanism, attention mechanism, right? And we actually wrote one complete program from scratch for attention mechanism, right? Now, for attention mechanism, the program we wrote from scratch, what was the whole idea that, let's say, uh, is it raining today? Is it raining today? Right? Is it raining today? If this is my question, then my model, when it is generating the answer, basically for the next word generation, it would go ahead and calculate the probability based on the input. That is, it is calculating the attention for generating next word, or we can say for generating, for generating next word. It should give, it should give, it should pay attention to which part? It should pay attention to which part, right? A very simplistic explanation of attention mechanism. We wrote our small attention mechanism of in PyTorch ourselves. We wrote that. And basically, attention mechanism is not a complex mechanism. It is basically calculating the dot product, that is matrix multiplication, calculating the dot product plus calculating the probability. Calculating the probability. This is a very plain attention mechanism. Now, what happens basically, this attention mechanism keeps on growing complex. That is, there are various kinds of attention mechanism and multi-head attention. When attention mechanism is increased for each and every word, then basically it goes ahead and forms the transformer model. It goes ahead and forms the transformer model. Now, basically, we have actually discussed enough that now we can jump onto this, but there is one pending discussion on how transformer works, right? But that we would go ahead and talk once we will have a look at, all of these things in fine tuning. We will have to see that what are the layers involved in fine tuning, which layer should we fine tune, and all of these things. We'll have to look at it. Now, the point being, we need to know the variables inside the model, and we have already built these models, but we'll have to understand that those variables inside a model, you know in order to understand that how it needs to be fine tuned for a custom problem and all of those things, right? Now we come to Hugging Face API. So Hugging Face API is a complete, mostly it is a wrapper over generative AI, not just generative AI. Actually, I would say it is a wrapper over transformer model. It is a wrapper over transformer model. Actually, all of the advanced models that are getting trained, you know, it in it basically transformer API or the Hugging Face API, uh, it will it has more, it has all of it basically, until and unless you're not going to create another foundational model like, uh, something like chat GPT or something like that, that you want to create one more foundational model of yours. uh, you will not need these things. You This transformer model is complete fit for industrial usage. You can do all sort of things from this transformer API, not transformer model, transformer API. So this Hugging Face API or transformer API, right, basically is actually giving you knobs for fine tuning all kinds of model. What kind of model? Basically, now what we had discussed already, we built ourselves encoder models. We built ourselves the encoder models, right? So basically, we built ourselves encoder-decoder models, sequence to sequence. We have seen how they work internally. encoder decoder models. Although what we were building were very basic models, right? Not industrial based encoder decoder models. And then basically it will go ahead and create, transformer models. You can go ahead and fine tune transformer models. Now in these transformer models, you can go ahead and basically, actually, this encoder should come here. In transformer models, these are the architectures. It has encoder models. It has encoder and decoder, encoder decoder architecture. In transfer, these are types of transformer itself. And then basically it has diffusion models, or we also have vision transformers. We also have vision transformers, right? And then only decoder models, only decoder models. We also have only decoder models, right? These are the kind of, mostly these are the kind of models. Then it also has diffusion models basically. Now let's discuss, although we have discussed in brief that what these models are, but let's have a small refresher here. you know we'll have a small refresher that what this is. So I'll just start with, what is, all of these are built using transformer architecture only. That is multi-head attention, not simple attention, multi-head attention. Last time what we saw was simple attention. So if we talk about simple, the encoder models, you know, encoder models. Now the architecture will usually have, that is, the architecture is, that is, if there is some input, then it will go to my model, encoder model, right? It will go to my encoder model and it will convert into a context vector. It will convert into a context vector, right? And then this context vector would be read by decoder models or decoder part of the model, and then it will produce the final output. It will produce the final output, right? So when we say only encoder models, the decoder part is not present. So basically what happens, that input is plainly converted using encoder models into context vectors. They are just converted into context vectors. Then on top of these context vectors, what we can do is we can add additional layers, right? What we have been doing, we can add linear layers and all those things. Like we can add additional linear layers, etc. for various tasks such as classification, right? Classification we can use for classification, converting of text into embeddings or vectors. Then basically it can also be used for like name entity recognition, that is finding of entity in text. That is, let's say you feed in some text, it will automatically find that this is human, this is person, this is city name. And you can fine tune it for your custom entity names also. Let's say if you're working on any medical domain, then you can fine tune it that, okay, this is a disease and this is a medicine. And you can fine tune it on your own terminology. And then on top of that, basically anything that is related to language understanding, right? That will be encoder models. You have to choose your models very carefully. The reason being, it doesn't happen that you use any model and you just throw it away. Although nowadays it has become a fashion that if there is any problem, you go ahead and use a LLM. For initial problems, that for prototyping and for initial problems, it will help. But once your solution grows complex, I mean, you start hitting the LLM, or customer is coming to your application or anything. Usually in B2B this is fine. In B2C, what happens that when a lot of customers, they start coming in, they start hitting the model, you exhaust with your like beginners plan, and you have to go for a pay for per hour basis and all of those things. So then basically the solutions become very costly. And this also happens in B2B also. As a result, the solutions become very costly. Then we have to carefully choose our models, you know so that we make an AI that fits into our pocket. It doesn't have to blow our budget. Now so it's very important to choose our models. Some of these models may not be, all of these models may not be provided by AWS and all of those things. And there is where Hugging Face API comes into picture, right? Although AWS and Azure, they have directly now integrated with the Hugging Face models. They do provide with lot of support to directly host and fine tune these Hugging Face models, right? Classification is there, okay, vector finding, entity, text. So any task, wherein summarizing by picking up only important points. See, this is not able to generate text. It is creating a context vector. It is creating a context vector, and then after that you can have your own layer to give some output. So basically this is non-generative model. This is not a generative model, but yet it works very good in classification, summarization, where rephrasing is not an option. you know you have to summarize in such a way that it only picks up important sentences. This is also one way of summarization. It picks up important sentences. Question and answer in such a way that answer should be strictly present inside the context only. That is, it will not generate the answer, it will pick the answer from the context. you know so these kind of problems. So at many places the hallucination can be completely gone. Basically, if you ask a question and it gives you an answer, so what is happening? There is question and answer. The answer is very strictly from the context only, right? So when you have these kind of smaller problems, then basically you can use encoder models. uh, but again, encoder models are not that very huge. They're not in multi billions of parameter. They're in small millions of parameter and all. They will do our job, like BERT and T5. T5 is encoder decoder model. Like we have BERT model is very famous in this case. We'll see some examples right now. And then we have the decoder models, the generative models, that are creating all of the fuzz in this word, the generative models. The generative models basically, uh, we got a new model, Gemma, yesterday. Gemma, I guess it's 3 billion model or so. Gemma 3 billion, right? And then we have the fee models from Microsoft, Llama, right? All of these are some of the famous models. Then GPT models, obviously we have GPT-2 model that is open source. So all of these models are generative models, right? So these generative models are excellent at generating text, generating images, and even with the audio. So like we said, we did create try to create one encoder decoder model ourselves also. So basically, internally it is trying to we are trying to map the input and output, and then there is a logic how this input and output mapping should happen, that is written inside the model. So all of this complexity now is being handled by Hugging Face API. Right now, without wasting much of the time, we will directly go to our Hugging Face website. Directly go to my. Everyone would have visited it. Like Hugging Face AI model for AWS. This, if you see here, this is huggingface.co. This is, and if you see, it already has a lot of things. You can actually literally, just go and search a lot of models here. These are the parameters you can search. What do you want? What is the based on task? If you want audio, text to text, image, text to text, visual question answering, document question answering, video, text to text, visual document retrieval, right? Computer vision, depth estimation, and all of those things. Lot of these models are already present. That covers most of the use case. But like I said, uh, if obviously the aim is you want to create something novel, you want to create something new, then basically whatever the knowledge we have discussed in the basics of the PyTorch, we can use that and create a model out of scratch. Sky is the limit. You can create any kind of model that you wish to. It's just that the training of the model will be very costly, and then we also need huge amount of data. So when talking about data set, there is also huge amount of data sets like audio, document, geospatial, image, tabular, text. and all of these data sets are already present with us, chat gpt prompts and reasoning data sets. So all of these things, spaces, we can explore these spaces. Spaces are basically wherein they try to basically display their model. Not all of these spaces are active because obviously they use some gpu and etc. But if you see, this is actually the space is actually the Gradio UI, what we have built previously. This is a Gradio UI using which they have hosted on the website. But like I said, this is not to be used in production. Gradio UI is something that we can use for demonstration purpose, not to be used in production. This is a Gradio UI using which they have hosted these models. Right? You can use any, I guess, in the input. I do not know, advanced multimodal generation. It is trying to generate image. Yeah, it will keep on happening. In the meanwhile, we'll explore other things. Right. This was Barbie dataset. This was the dataset that we used. You know, Barbie dataset. We trained Barbie dataset, and then we trained, for question answering thing. And the last Saturday session, we trained one model that was so small. That is, the model was even, I guess, 1 MB model, and it was able to solve puzzles, some complex puzzles also. Like I did show you previously, that it was able to solve some complex puzzles when we are putting some complex puzzles, that this is how person is moving, person is going there, then this person took the ball from a person b took the ball from a, and then so we built this model from scratch, right? So this data set was also taken from here itself. It has a very good 10,000 such data sets are already present. Right. So these spaces are already there. We can go ahead and use these spaces here. Right. You can have go ahead and add the community, and you can just go at any model. What is the recently released model? If you see most slides, most recently created. Right. So these are some of the models that are recently created, and Google Gemma should also be here. But yeah, I mean, right. So this is, I guess, this is the previous version, Gemma 3 4 billion model. It is a 4 billion model that has been basically done. And you see, this is the basic details of this thing. Okay, now coming back to our previous thing, that we want to understand this transformers package. So basically what we have to do, first we will have to install this transformers. But yeah, transformers is by default present with us in our API. Basically it is present by default with us. So yeah, transformers are present, so we can just go ahead and even anywhere you see from transformers, import transformers. So transformers has various models. So first and foremost thing, the first thing what we will try to do is we'll try to load any basic model. Right now, transformers have these APIs in a very structured format. These APIs are basically present in a very structured format. Right. So I'll just first try to import something from transformers, import something. I'll just take the tokenizer, because in tokenizer, we have been writing all of the tokenizers ourselves till now. And okay, I'll take any tokenizer. I'll not include any text. Right. I'll take this simple tokenizer, and then basically uh, every tokenizer is a different thing. So tokenizer is equal to AutoTokenizer. Now this is just for demonstration, don't worry about it. We'll just go through all of this API, how this API is arranged, and how we need to use it, what is for what. So tokenizer from dot from underscore pre-trained, and I can take any model. Basically I can take BERT, case, encased. This is a model that I know basically. Then I can take any text that welcome to Hugging Face classrooms, right? And then basically I can simply go ahead and generate my tokens. I can go for tokens is equal to tokenizer dot tokenizer dot tokenize and print token. Let it just reconnect. And previously we have been writing a lot of code for tokenizing them, converting into numericals, creating a dictionary and all of those things. Now all of that will be handled automatically. All of that has to be handled by the Hugging Face API. And transformers is the package in which all of these APIs are present and built on top of PyTorch. Let it run. It is taking a lot of time. Okay. But and sorry, Bert case encased. Okay, I guess let me just check. Bert uncased. It is Bert base uncased. This is the model that we are trying to load. Let's see what it has done. I don't think so. It has created anything. Add a fisherman hat to. Yeah, I mean, sorry. So basically, what in this thing, what has been done, basically a generative AI model. This is a woman, and a hat has been added to her. You know, so yeah, I mean, you can go ahead and play along. There are a lot of examples present, and you will simply enjoy this whole thing because now I understand that previous sessions might have been boring, but in order to understand that how this is done, and even at some places you will have to, if you are trying to experiment anything, you might be adding some custom layers on top of these models. So you will need PyTorch for that, and then basically we will need all of that. Okay, I'll just go with bird base. Okay, so it says tokenize welcome to jungle and double hash face hugging face classrooms, right? This is one function. There is one simple function wherein we can see the masking, etc. Right. If you see, this is something we have been doing always. You know, input IDs, token types, attention mask. Attention mask is basically it is trying to calculate that which text it needs to pay attention and which text it doesn't needs to pay attention. It is already generating the input ID based on its dictionary automatically. So all of the things that we have been earlier doing has already been automatically taken care this time. So basically, these input IDs are numerical representation of the tokens generated by the tokenizer. Now, each token in text is mapped to a unique integer ID based on model's vocabulary, like we have already seen, right? And then attention mask, we can just think of this attention mask, which parts of the input are important. When preparing the text for a model, shortest sentences are often padded with some extra tokens and all of those things. But yes, I mean, in short, we can just understand that, which of them are important for it. Uh, right. Now, the shortest way to use these transform is using a pipeline function of transformers. So the shortest way, again, like I'm saying, this is the for beginners only. You can go ahead and you can just play along with it. The pipeline, basically the pipeline API.
Anand, I have one question.
Yeah.
So in
Basically,
the call, yeah. So if we wanted to use the Hugging Face API or library, right, whatever the pre-built. So in the Collab, you have just a 4 line of code. How in order to, for example, I wanted to randomly use the any Hugging Face API in Python code, then what exactly library I need to use?
Yeah,
Or should hmm,
we'll have to install this transformer API. If you just go ahead and see pip install -u transformers, even if you go to just Hugging Face documentation, you'll find all of it that. So basically in Python, we'll have to install this manually,
okay,
transformers, right?
got it. Okay.
Now in Collab, we are getting all of this automatically, but I'll let you know one small session on Docker basically. I'll Dockers you might be using, some of you might be using, but a small session on Docker I'll take maybe later on, how to prepare all of these libraries for deployments and what are the best practices for deployments and all of those things. So we can have a look at that, right? Installation, pip install transformers, right? That's it.
Yeah.
So in Collab already, I mean, like some 2 years ago, this was already included in Collab. Right. Okay. Now, basically, I was talking about the pipeline. So pipeline, what it does is pipeline is basically it gives you some lot of functions. Pipeline is a kind of it is, as the name says, it gives you a lot of functions ready to be used. Like, you know, uh, all of the pre-processing it will take care of, all of the model inference it will automatically take care of, all of the post processing it will automatically take care of, you know. So basically if we just have a look that what are the tasks that it can support, so basically we can go ahead and do some basic tasks. This is like most of the tasks you can go ahead and do from pipeline also. I mean, you don't only when you need to fine tune your model you will need the auto API. For fine tuning only you will need the auto API. So it all depends, how do you want to use it. The pipeline is nothing. Pipeline is just one line of code and that's it. But now I'll just talk about it later. So let's say, for pipeline, you can go ahead and you can do text generation automatically. So you just need to do text generation. You just need to use this function of text generation. I mean, you'll have to provide this parameter of text generation and automatically it will take care of your text generation thing. Then it can automatically take care of the name entity recognition. It can automatically take care of the NER, name entity recognition. We'll have a look at all of these things because obviously I mean, it doesn't make sense just talking about them. We can just, with 5 to 6 line of code, we can just build our question answering. We can load the question answering model and we can just use it, then apart from question answering, it can have summarization task, translation task, summarization. Summarization, it can automatically do. Then fifth is translation task. It can do the translation task. And just mind it, all of these tasks, we are just using CPU as of now. Although in CPU, they will be slow. They're not going to be very fast, so they're going to be slow. So let's try to explain, let's try to, what I'm saying is explore that what is basically, what we are just trying to do here. Okay. All right. So we'll just see that, what are the things that are present here. So first, let me just prepare this pipeline functions. Okay. So I'll just go ahead and we already have a transformers. So from transformers, import pipeline. And, I'll take this time. First, I'll take is text generation task, right? I'll go with the text generation task. Even if you see in these examples, they are using pipeline. Yeah, and even if you go ahead and see in the Gemma to the example, Gemma 2 billion model, small, I can use a Llama 1 billion model, Llama 3.2 1 billion. Okay. Now, simply I need to, load this. I can use pipeline. Now in pipeline, I can just use this text dot generation. I just need to use this. That's it. It will automatically load a default model in the backend, but I can provide the model parameter that this is the model I need to load. Right. Okay. GPT, let's say for now I'll use GPT-2 model. GPT-2 model is a free and open source model, right? So this one we can use. And then we can go for generator, something this, right? Let's load it. It will take some amount of time to load. All right. Prompt, I'll take a prompt and I'll say that how can this, how can we establish harmony in this word? Let's say something like this, right? And now I can just give some result. I can collect my results in generator, right? Maximum length and results of generated text. It will take some amount of time, like I said, it is going to take some amount of time to generate. So, this is all the code that you need to write the generators. You can use the model from Hugging Face directly. And it says in the long run, it will be difficult to see how Word could be any better. At the outset of this essay, I will try to avoid talking about political and economic issues that are at the stake in the 21st century. There are many possible real problems that the world today may face, but I'll try to and so and all of these things. It is not talking nonsense. It makes sense. A very small model, GPT-2, a very, very small model. If you just go ahead and in the meanwhile, you can just go ahead and play with it and just say that, what, uh, create a dragon in the background. Let's see what happens. I don't even know. Let's generate. Okay. I guess just one image it was trying to, uh, because these are GPU intensive tasks. Anyway, these are some heavy tasks already. Now, if we just go to GPT-2 model, OpenAI community GPT-2, if you see it is a 137 million parameters model. However, I guess the input length and output length is also limited in this model. We'll have to find it out. This is the smallest version of GPT-2. GPT large is also there, GPT medium is also there, and GPT XL is also there. But we'll be experimenting with GPT and Llama models. Basically, we'll try to experiment with these models, right? And they have their own tokenizer and everything also. You can use in this way also, but do not need to be confused that okay, this is how it is. Yeah, you can use the pipeline also, and all of these things, text generation, the same thing that we have done right now, right? And I do not know where is the total input size, because what matters the most is total input size and the total output size. This is what matters. Okay, we have text generation, then question answering is also pretty much similar, but for question answering, we can use any other model also instead of simple one. So I can just go ahead and maybe I'll just go create pipeline for question answering in Hugging Face. All right, model Distilbert, it has automatically selected the model for me. Okay, and then QA underscore pipeline question answering. Okay, now what is happening here? This is not a generative model pipeline. Now, okay, question and context is here. What is capital of France? Now, what I'll try to do is I need some text about Paris. Let's say, I'll get it from somewhere, or I can just go to chat GPT, right? Give me a small 100 length essay on Paris and France. Okay, we have this. Let's try, because the length will also have to take care of the length. Okay, we have this city of light. Make sure the text is in proper format. Okay, this is my context, and what is city of light? Okay, Paris, the capital of France, is known as the city of light. It is not generating answers, right? It is basically picking up from our context only, start and end. I'll ask something else. Together, Paris and track billions of offline. I'll say that how Paris and France are related. No, this was not Paris and France. What is capital of France? This it will easily give Paris, right? So basically, what is happening here now? There might be a lot of questions. It all depends on your use case, right? Now, just imagine this is a very small model, and I am currently loading two models, GPT-2 and this one. It is occupying 5 GB of my RAM. I'm running on CPU. I'm not even running on GPU, right? So it really depends on the use case that we are trying to crack, right? What is the feature that we want to provide to the user? Depending on the use case, it's completely free. We can host it anywhere in a medium sized. But yes, again, like I said, it depends on a lot of factors, because nowadays everyone expects that if you are telling them you have an AI, it has to be at par with ChatGPT 2, or sorry, ChatGPT, not ChatGPT 2. Okay, then another I can take is summarization. Let me show you summarization. Summarization, again, I'll ask to create a pipeline on summarization, create pipeline on summarization, and create sample text to be summarized. Oops. Okay, so here it is, minimum length and maximum length we have already provided. Summarization, uh, now basically what is, I can directly provide this pipeline as summarization. It will by default pick up the model, right? And it is actually picking up the model is Distilbart CNN. This is the model it is using. It is again not a very huge model, right? Now, but it is a 1 GB model. And you see, this time it might have increased. Yeah, it did increase my RAM. And summary text, this was my summarized version. The summarized orbital discovery completed in 30th mission, attribute to the shuttle's program, longevity and success, the missions later. But if you see, there is no hallucination in this case. No, encoder does not hallucinate. Only when it is decoder, it will hallucinate. When it is trying to generate, right, it generally hallucinates. There is no hallucination in this. The mission latest 15 days, 2 hours, 14 minutes, traveling 6.2 million miles and completing 238 orbit rounds. All right. Similarly, you can just go ahead and go ahead with the translation thing also. You can do the translation. One more example. I mean, since I hope this time everyone should be enjoying it. Is it enjoyable, team? Hi, everyone here. All right, cool. Yeah, gone are the tough days, right? Object detection. I guess this was the whole thing that everyone was waiting about, fine tuning your own models and everything. But yes, I mean, uh, now we have to go through certain background to reach to this point, because as we go in fine tuning some tough models, we will need all of those PyTorch. If I teach you to deploy these models, we will need basics of PyTorch, right? All of these things we need. And then as soon as there is a problem of, we have to introduce one linear layer, then basically it would had confused you simply. So hence we had to cover all of that. Now we go for any object detection part. Okay, I'll have to hunt for an image. Now Hugging Face has some sample images. Hugging Face sample images, right? Okay, let's try with this. This is a very small image. Sample images, car or something. Okay, car. And okay, anyways, this is a very no. Okay, we can have a look with this image itself. It's a base 64 image, not the link. Anyways, I will get it from somewhere. First, let me. Okay, so object detection pipeline with a sample image. No, I'm still not able to get it. Either it is giving me option to save something. Anyways, let me save it in that case. Okay, right. Okay, what it has done is detections. All right. Read image from local disk. Okay, let me just upload the image. So yeah, it will again load from my local itself. We can skip this thing of uploading. We can directly even read it from the disk. And let's complete this one. All right, it is going to load a new model this time, and I guess it is. Yeah. Okay, so what it has detected this time, clock, box, car, person. So it has even detected a clock here somewhere. I do not know where it is. So it might have detected the image somewhere, watch, this clock, person, and the car. So yeah, I mean, all of this as of now is happening by default. You know, all of this is happening from the out of the box model, what you call. Right. Anyways, just a small one. You know, because everything is incomplete till the time we do not know how to, uh, do it using the basically we should now if let's say I go towards Gemma to be IT model. So for this I'll have to sign in, right? I'll have to log in, because if you try to load this model directly, it will give you an error. Let me try to pipeline for loading. Okay, this is not we want. Using pipeline. Okay, all right. Model text generation, but there are a few more options we'll have to see. First and foremost thing, I'll have to restart my runtime because I this is a bigger model. This is a 2 billion model that we are trying to load. First, let me try what happens. Let's see what happens. So I'll just go here. Okay, I'll have to import all of those things again. Okay, done. And now let me try. Okay, it gave me an error. What is the error? It says error is you are trying to access a gated rep. So basically, you have to sign a small, you have to agree on terms and condition for this. You will have to create your own, login here. So you can go ahead and create your, and then, okay. And then if I again go to Gemma 2B IT model,
So Anand, some of the models on Hugging Face we can use for commercial use, right? Or we need to read all.
you'll have to read the license for them. Let's say Gemma and all. Let's say the Gemma license. The Gemma license, we'll have to find out what it says. Some of them say that if the revenue of your organization is greater than XYZ, then you cannot use it. So basically favoring more startups and all of those things. Or some of them then they try to limit that, if the revenue or if the usage of the model is greater than this and this limit. So you'll have to go ahead and read that. Okay, this
Okay.
is the model. So I have already, got the access of it. Basically, there will be a small agree to terms and condition, which you might have to do. And then basically what happens that you will have to log in here. You'll have to log into our CLI. So we'll just log into our CLI so that, we can, I guess the command is, I forgot, Hugging Face CLI. Hugging Face CLI login. Right. Okay. Okay. This is what it is. And you will have to get your token. And I'll just tell you where your token is going to be. Got it. Okay. And my token is there. Till the time I'll let it load. Right. And there's a prompt also. It is a 4 GB. This small model, 2 billion, is a 4 GB model. We are loading a complete full model here. Let's see what happens. If at all my system, I hope so, it should be able to do it, but let's see. I guess it is greater than 4 GB. Let's see. Yeah. So this 2 billion model or 4 billion model, you can load it on your local, and then you can generate your own data sets, or do a lot of things you can do here. Now, a simple thing being that this is my Hugging Face ID. I can just go ahead, and from here you can just go ahead and generate your tokens. Why is it not showing tokens? Settings and access tokens, right? I've already created one, right? I created recently for this. You can go ahead and nullify this and create a new token, right? You can do this, right? So that's it. And I guess let me load this model and let's see, let's play with this model for a while, right? What it can do, what it cannot. Let's try to generate some programs from it. And then this model itself, this model or the llama model will try to fine tune them, fine tune these models. It is going to take some amount of time, but let it be.
So Anand, for fine-tuning the existing model, which is already published on the Hugging Face, we need to first, we can directly fine-tuning on that, or we need to download the complete this model and fine-tuning. What
You
are the
will have
procedures?
to download and fine tune on your machine, or you can, if you want to fine tune on Hugging Face, then you will have to. I mean, there are some free credits for fine tuning, but then either you will have to fine tune on your own machine, or you'll have to. Here is, you know, get Hugging Face Pro. There is GPU, how much GPU you can use. So all of this thing you can use, or you can, some of the models like Gemma 2B and 1B, they can be fine tuned on freely available this collab also.
Okay.
So if you see, my usage has shot up to 11.5 GB, and there is a chance it may crash also. Let's see. If it crashes, then we'll add a parameter to it. But I guess, yeah, the model has already loaded and it is just processing the results. Since it is on CPU, so it will take some amount of time.
And once we'll fine-tuning, right, from our machine, and now I wanted to make it available then as on cloud or somewhere, right? So what are the procedures for that to publish
Yeah,
again that
you will have to use either VLLM framework, or maybe some other framework like Hugging Face also has inference framework. So you have to use Llama CPP. These are the frameworks you will have to use to host your model, and then expose it through an API or through an UI, basically application that you want.
okay.
Because I mean, so your customer will not wait for this much amount of time. So then you need to add a lot of GPU power to, you know, make it fast, just like all of these chat GPT, etc. are having. Or else, if your process is not, I mean, a lot of businesses are exposing their models in such a way that you enter the task, and then we will add it to the queue, and then we will return it when it's done. So some of the tasks, some of the heavy duty tasks can be done in this way, rather than you being in pressure that, okay, I need to output it right now, because a lot of GPU is wasted in this thing, because you will have to maintain a huge amount of speed for that. Okay, anyways, let it load. In the meanwhile, we'll continue with our small theory that we have to further. Pipelines are good. Pipeline is a good API, right? Pipeline API, what we have just discussed is a pipeline API. Pipeline is good API for, automatically running these models. Automatically, when you want to run these models, it takes some default things, uh, and then, automatically running the models. It is very good. Okay, I guess it is there. And let's have a look what it is saying. Okay, really something, because obviously this is one of the recent models, right? Meditation has wide range of positive benefits for both mental, physical well-being. For some includes mental benefits, physical benefits, and whatnot. Let me this time, we'll play with it. But it took 6 minutes for you to generate the data. Right. Okay, this time what are the benefits of meditation, and then what you call, this is one way of doing it, right? What I'm doing is I'm loading full model as of now. It is taking me 11.5 GB of data. Now, so what can I do? I can also do is I'll restart the runtime, although, you can go ahead and play with the model as of now. Then we can see how we can load the model with half of the memory. Let's say prepare me any or prepare me diet plan for weight loss and gym exercise plan, and I am average weight male, right? Let's see. This is also going to take some amount of time. Right. As of now, I've loaded full model into my system, So yeah, uh, what you can do with these models, you can do a lot of things. You can generate your own synthetic data set. I mean, this is 2 GB, but nowadays most of the systems have, what 24 GB GPU, 24 GB RAM, etc. So you can go ahead and let it be running over the night, and it can generate huge amount of data for you, mathematical data set or whatever legal data set you're working on, or pricing data sets, anything you are working on, anything you want to demonstrate, all of things it can be done. Okay, so pipelines are basically, they are for automatically running all of these things. And then they have one more uh, API, which we will be mostly using, that is the Auto API. Auto API. Now, this API basically what it does is Auto API. This is API for basically having more control over the model. You know, the Auto API has more control over the model. So basically, it gives you low-level building blocks. Auto Star, it gives you low level building blocks. It is a low level API. This was a high level API. Pipeline, simply you take the pipeline and you just get it running and done, right? It will give you a lot of functions, like obviously we already had seen tokenizer, and we were using AutoTokenizer. AutoTokenizer is for loading the tokenizers, right? And then it gives you trainer API. Trainer API is for fine tuning the models. It is for fine tuning the models. Fine tuning or training the model, whatever you wish to. I mean, you can train a model from scratch also, right? Then basically, trainer, all of the complete training loop is being taken care by this complete training loop. Complete training loop can be taken care by this, and then it has individual auto functions, have lot of individual functions, that we can use, such as we can go ahead and use auto model, auto classification, auto classification, then auto generation. So there are various classes that are present. Let's have a look one by one. Easily, we'll go it very easy, right? And this is still running. Let it be. Right, okay. Uh, in the meanwhile, we'll write our small functions, but let's wait for it to learn. Let's wait for it to complete at least. Anyways, we'll write a function by them, right? First is auto API configs. So basically, with any model that you have, you know, you can take any model. That model is going to have configuration. It every model in Hugging Face has a configuration file with it, right? So basically, it reads from the configuration. From the configuration, we get to know that what kind of model is this, how many layers are present in this model, what is the attention mechanism used in this model, how many number of attention heads are present in this model, right? And all of these things we can get ahead from, let's say for this time I'll use this the same BERT base uncased model. So let's say I'll use first I'll from transformers import AutoConfig, right? I'll run it as this thing finishes it till the time model underscore name BERT base uncased and auto config from pre-trained, right? And print the configuration. We'll try to print the complete configuration. What is the configuration here? Okay. And it says I am AI chatbot and cannot provide you medical or personal. This should be considered as substitute for professional. Always consult XYZ. Diet calorie deficit. Aim for a calorie deficit of 500 1000 calorie per day. Lose 1 to 2 pounds. Use calorie tracking app. Focus on whole unprocessed food, fruit, veggies, 5 9 servings per day, protein, whole grains, healthy fats, limit process, and drink plenty of water. All right, cool. I'll have to unload this model because this is taking just too much amount of memory here. Right. And then similarly, we can load any model and then we can print its configuration here. All right, I guess it is done. Okay, it's done. Okay, so if you see, lot of information is there. Please note, it's still optional and BERT architecture is BERT for masked LM architecture, dropout, classifier dropout, gradient checkpoints, layer normalization, max position embedding 512 is the size of the embedding that we have been using earlier. Number of attention heads 12, positional embedding type absolute, transformer version 4.52, vocabulary size 30522. If you remember, this is something we have been using earlier also, vocabulary size, all of these things we have been using to build our models. So this is the information about those models. Next, we have already seen basically, the tokenizer, but yeah, I mean, let's see it once again since we are visiting this tokenizers. So we'll go with the tokenizer basically. Again, what we have been using that, purpose is basically, to load and correct the tokenizer for a specific model. So basically it converts your text into numerical IDs of the model. I mean, that basically a model understands, right? What we have already seen in the first example itself. I'll again go for from transformers, import AutoTokenizer, BERT base uncased. Welcome to Hugging Classrooms. Again, the same example, I guess, tokenizer, that's it. There are some more functions present in it. For instance, you can just go ahead, and you can go for tokenizer dot vocab size is present, right? You can get your vocab size, tokenizer dot, and let's say I'll get is convert ID to tokens, so these were my tokens. Now then I converted those tokens back to ID. This was my tokens, and then I converted those tokens back to ID. Now since we have built these functions ourselves n number of times, we understand what is happening behind them, right? Next is very important function, basically the auto model function, right? The auto model functions we have. So the auto model is to load the base model architecture, right? Basically the loading the model, and then the code transformer model, whatever it is, it doesn't cares about what is the architecture inside. It will load the model, right? And we can just go ahead along with auto tokenizer. We'll also have to, I'll just restart it, and this time we'll use the same model. Import torch from transformers. Torch is not required, I guess. From transformers, import auto tokenizer, and these all auto model for sequence classification and all of these are already present. They are basically the individual logic based on the task, right? And you can go ahead and create your own also. How? Using PyTorch. These are PyTorch models only, right? Auto model for sequence classification, and then I'll go for an auto model, right? Auto model simply, and then tokenizer, and then this is basically from pre-train auto model, and this is basically loading the model. And here I can just go now. I can very well go ahead and use this model, but this model is an encoder model. I'll have to use something, either add a classification layer or something on top of that to use it, right? Because it will give me the embedding things. Let it load. And then we'll try to build certain small applications, using this. Okay, first let's say now this time if I want to use it with torch dot no underscore grad, I can use it, and output is equal to model, and I'll have to take some input. Input is equal to tokenizer, welcome to Hugging Face classroom, and basically this will take. So basically here this input is being provided. What we are trying to do, we have tokenized this, and this directly accepts this. We have already seen so many times, why we have been, and basically it is actually, this is returning me in form of tensors input. If you see here, if I just try to print this, so it is returning me in form of tensors, and then I can go ahead and generate my output like we have been doing earlier, right? Then basically we can use it for various purposes, like some tasks like sequence classification, token classification, question answering, or something like that. Let's try to use this model, for maybe we'll use for some text classification example, right? Let's use it for text classification. We have already loaded these models, right? We have already loaded these models. So what we'll try to do is, I guess we should load a different model for this. Let me fine tune crystal bird. Okay. So most of these models will give you a direct example how to use it. And model details. It is for text classification. The classification types, these are the data sets on which it has been trained on. I'm trying to find the classification labels. And if you see, these are the evaluation results that are present of the model, which is pretty high, uh, on the glue data sets. These are various data sets on which it has been trained on. Uh, we can go ahead and see that whatever things are present, but I guess this is 1 and 0 only, rightly. Yeah, let's try to see. Okay, I'll take this model. Okay, and instead of this, for auto model name, can directly take model underscore name. This is my model name. Model underscore name. Then we can give model underscore name. Let's first try to load this. Okay. AutoTokenizer model. And then I'll take some input samples in tens. Text is equal to, movie was great. Movie was good in start, but I lost interest in the end. In fact, I felt asleep. Somewhat controversial statement. I mean, not exactly saying that it is good, bad, or something like that, right? And then I will convert it here. Text. Okay. Don't worry, it can be done directly also. You do not need to do all of this, right? Now here, this is okay. It has got this input tokens, and then here we have our output here. That's it. We give. We can actually this giving me as model logits, logits predicted class ID. Hmm. Base model output has no logits. Okay. Model for sequence classification. We can take this model here. AutoModel. The correct class should be for sequence classification. So basically based on specific task. Okay. And then we have this, and in the last we can just go with our last function, that is whatever the predicted class is there. Negative. It says the answer is negative, right? You can take anything else. We can take text as I used to like this place before previous year. Okay. Again negative. So it is basically able to get, uh, what it is trying to say. Even if we print this logits here, right? There's no specific information here. Right. So basically what we have done is for this specific model, auto model for sequence classification, we can take, there are many such classes that are present. Auto model for sequence classification is one. Then we have for token classification, question answering. For language modeling, we have for casual LM, for masked LM, for sequence LM. What I'll do is basically I'll create a small document here, auto model, various functions, or you can actually find it in the Hugging Face also. I mean, I'll be also copy pasting from Hugging Face itself. So you can either find it there, or I'll provide this notebook here wherein you can find all of these functions. We'll have a look at one more example, because more of the examples we look at, the better we'll understand that, will this time I'll have to reset my runtime so that I save my space, right? Again, we'll try to load one more GPT-2 model again this time, right? This time auto model for casual LM. Instead of this, I will use auto model for casual LM. I'll just generate it, use auto model for casual LM for GPT-2. Okay. Once upon a time, I'll ask something else. What happened in last episode of Game of Thrones? I do not know it has been trained on this data or not, but let's try, no harm in trying. A small model, GPT-2 model, we can get from the config that what is the size, maximum size of this model. Let me try to GPT to max input and output size. Back is GPT to GPT-5. What happened in last episode? I think it was a little bit of surprise to me that the game was so much more than just Game of Thrones. It was game of survival. It was okay. It is actually, I should 200. Who was last king in Game of Thrones? We're trying to find out that what is maximum size and position parameters. Vocab size is this. Who was the last and was the first crowned king? The king of the, and this is all rubbish. It is hallucinating. Crowned the king of the world, who was the first crowned king of the world. I mean, it has started hallucinating basically. I mean, it is a very small model, you know. If you ask it from Gemini to be, it will answer you correctly. But I mean, just we just needed to check that how model for casual LM usually works, right? Now, basically, what we have done here, the tokenizer. First, we loaded the tokenizer. It has actually loaded it using GPT-2 tokenizer. We could directly load it using AutoTokenizer also. AutoTokenizer, I mean, basically, it doesn't have to depend on any specific model. You don't have to AutoTokenizer. You can simply use AutoTokenizers and AutoTokenizer from pre-train GPT-2, okay, AutoTokenizer, and then tokenizer. AutoTokenizer is not defined. Okay, AutoTokenizer, and then we get with the tokenizer. Okay, and then model GPT casual LM dot generate, right? This is basically, here we have again created our input things, and this is used for generating simple generation, and this is my generated text. That's it. This is how simple it is. Yeah, and the same way you can go ahead and load any other model. Gemma 2b, if you see, we loaded it from the pipeline basically. But yeah, I mean, you can go ahead and load it this way also. The Gemma 2b, it is going to be loaded from the same similar kind of things. So this was a small introduction of, very simple introduction of, how we are using auto models and everything. After auto functions, we will take a bit of journey into model customizations, but we will see finally the model customizations we'll see tomorrow. Now in model customizations, we'll try to understand there are various kinds of model customization, and this is a long topic. We might have to cover it for at least 3 days, and we'll have to see a lot of experiments also. Right. Now model customization, what happens in model customization? What we have been trying to do till now is basically using the PyTorch. We have built our models from the scratch, right? We have built models from scratch. What we have not done is, right, this is called as building a model from the scratch and training from scratch. We have been training all of the models, training models from scratch, right? That is, we are trying to prepare a foundation model. We are trying to prepare a foundation model. That is, this is also called as pre-training the model. Or actually, pre-training is one more step that is basically, involved in adding lot of unlabeled data and all of those things. So we'll not call it pre-training. Basically, this is training, and we have trained a foundational model. Now, once we train the model, right? Once we train it, and then what happens? Second is, most of the time when we are training huge amount of data, I mean, in real time use cases are huge, right? They're not going to be simple. That they're not going to be simple use cases like uh, something, wherein we can simply have text classification or just find out that what is the entity. I mean, no one pays money for that, right? So basically they're going to be complex, so you need big models, you need big models, and then on top of those big models you need is huge data, right? So basically the solution is fine tuning the models, fine tuning. That is, we use existing model, that is we use an existing model, and on that existing model we add custom knowledge, right? We add some custom knowledge. There are various ways of doing this. There is no single way of doing it. Based on the model, we add all of these things, right? Uh, for these things, like we already have, we have all of the required functions here in Hugging Face, how to fine tune the model. So we don't have to write anything specifically. We just need to understand, right? That based on for LLM classification, for LLM fine tuning, there are separate methods. Just we need to change the methods for that, but we need to understand that what is actually happening behind them. Now, like I said, that this is my model. Let's say this is my model. Ideally, I should be showing all of this via visualization, which I will try to prepare in the next session. So this is my model. My model is a big set of tensors, huge set, and some millions of parameters. Now, one option is obviously that what I can do is fine tuning. Why fine tuning is there? In my model, I have various layers. These layers on which I have been training my model, right? I have various layers. And then I can continue to freeze few layers that I will try to train my model, but I will only train last of my few layers. That is, let's say last 2 3 layers only I will train. This is specifically useful in the case where the layers are learning some specialized kind of data, right? Very useful in image kind of data, in image learning. In image learning, this is very useful. That is, you keep these layers as it is, and you just basically fine tune or you train last 2 or 3 layers or whatever is suitable, right? You just train them, and that's it. And then you have your new model. You have trained very less parameters. You have trained just this part of the model. You have trained very less parameters, and now your model also knows about your custom data. It knows about your custom data, because in these cases it is very tough to train all of these layers, and it might take huge amount of time, huge amount of data that you don't even have. You don't have all of this data. It might have learned so millions of knowledge, some millions of information, so many data points, and all of those things it has learned, right? So this is one way of doing it. However, in our case, in text thing, what usually happens, basically our models are so huge. The 2 billion model, it took around, what in CPU it took around 12 GB of data. It may be on CPU or GPU, it is going to take similar amount of memory, 12 GB of memory. That is, if I have on my system 12 GB of RAM, this 2 billion minisecond model is going to just use all of it, right? This is just for running, by the way, right? Not even for training. But for training, fine tuning, right? There's a specific formula by which we can calculate that how much memory is it going to take based on number of weights and biases it has, right? We can tentatively calculate that what is the memory it is going to take. We'll just discover that formula soon after the discussion, maybe. Then in training, what is happening in training, that it will at least occupy at least 36 GB, this 2 billion of model only. It will, if I try to full fine tuning means This is partial fine tuning. I only fine tune this part. Partial fine tuning, right? Full fine tuning is basically I try to fine tune this whole model. I try to fine tune this whole model from top to bottom. Top to bottom. Fine tune, not train again. That is, although this will yield full fine tuning is basically full fine tuning, because what is going to happen in that case, you will have to load the whole model into the memory and then all lot of parameters into the memory and then start fine tuning. So full fine tuning yields best results. It yields best results, but for huge bigger models, this is a costly operation. This is a costly operation. For I mean, this 2 billion itself, it is going to take a lot of memory to train, and 2 billion is a very small model. It is a very small model. You will have to first prepare all of the data set and all of those things, and then basically you need to train all of this model. So basically there are various ways of coping up with this problem. We do not go complete fine tuning. Then either what we do is, you can go ahead with doing partial fine tuning. Again, even in case of partial fine tuning, what is happening, it partial fine tuning, like I said, the case wherein we freeze some part of the model, we freeze this part and we fine tune only this part. What is happening, since it is a text model, so basically it will not learn that well. So basically what we can do is, basically one of the options is, now this is just for understanding, because the real thing that happens in the backend is different, and that we will discuss when we go there. So I mean, we try to create a smaller miniature version of this model, right? We try to create this. How? Let's say my values, my matrix, one value, let's say the value at this is 4.2163782. I will just take 4.2. I'll just take 4.2. This process is called as quantization. Quantization. Why quantization? 32-bit data might be required for storing this number, but here I will require only 16-bit data for storing this number. As a result, now earlier I was using 12 GB for storing this model. Now I will only need 6 GB or 5 GB, whatever, I mean GB, for storing this model. I can go for 8 also. For with 8, basically what is happening, my precision is falling. This is highest precision. This is highest precision. My precision is falling. And now what happens when you use all of these free models, cheap models in the market, and people keep on wondering why they are not getting the output? They say that, ChatGPT is giving this percent output good, but when you use and when you start using for some complex use case, you're not getting that output. The reason is because they are giving you a quantized version of the model. They're not giving you a full model, because obviously they also have to save bucks. They cannot throw money away. So basically the full model comes at different cost. The partial model comes at cheaper cost, right? And this is something most of the people don't even know. They keep on using for the business use cases. They keep on hitting this AWS Bedrock, etc. Now, uh, I should not be taking in names, but yeah, they keep on hitting these all of these things, and these publicly available models that are so cheap to use. Some are fully available, some are not. This information is not available to us, but yes, based on comparing the output, you can get an idea, because as you start quantizing downwards, you start losing accuracy. You start losing accuracy. You can load it in 1 bit also, right? Microsoft has one way. I still have to read that paper around, what is the logic they are using, but they have 1 bit loading of model also. That instead of 32-bit, it scales down to 1 bit. And basically, but they what they are saying is, in spite of scaling it to 1 bit, they're still able to run with good accuracy. We'll have to check. I'll have to go and check, what that paper is saying, and then I'll bring that information to the group also. Because this is, if this is really happening, then this is huge. Just imagine this whole 2 billion model or 16 billion model, you are just able to run it on CPU, but I doubt the accuracy, because if this would had been the case, Apple would not had been like struggling with putting their LLMs inside the phone and all of those things. Yeah. So these are various ways, in which you can go ahead and customize your model. You know Not just that, actually. I mean, there are various ways of doing it. Basically, you can add one more layer on top of it. I mean, not in all cases, but yes, in some cases it might be useful, wherein you take the input from this model and you pass it on to another model, right? So you can use all of these things. uh, okay, right. We'll keep this class limited to this, because the next topic is about, we'll have to discuss about the training API, etc., which again will be around 1.5 to 2 hours of session, and then which will start tomorrow along with some more information. In the meanwhile, I'll share this notebook with all of you, right? You can go ahead, explore these models,